Okay, we will continue doing mystery questions about RLC series circuit. Question number 1. Given an AC source to a pure resistance and a pure self-inductance of inductive impedance 61 connected in series, a pure resistance R and inductive impedance XL connected in series. If the phase difference angle between the electric current and potential difference is 26.57, find the resistance of the circuit. R is the question. So tangent theta, which is the tangent of the phase angle difference theta, is equal to XL minus XC divided by R. But in this circuit there is no capacitor. Xc is going to be 0. So directly we can write tangent theta in here. It's given as 0.5. 0.5 is going to be XL over R. XL is given as 61 divided by R. To find R, we have the cross product 0.5 and R. R is going to be 61 divided by 0.5, which is going to be 122 ohm. Question number 2. An AC source is connected across a series combination of a coil of certain resistance. So when it says coil of certain resistance, it is not a pure coil. That coil must have a resistance. I will represent this resistance of the coil by R sub L. An inductive impedance 20 ohm, which is XL. And a pure resistor. There is a second resistor connected in series with this coil, which is impure. So this is R. If the total impedance of the circuit is 25 ohm, which is Z, what is the value of the resistance of the coil? Calculate RL. We know that Z is equal to root of R squared plus XL minus XC squared for a series RLC circuit. Because there is no capacitor, X is 0, but there are two resistors. One resistance belongs to the coil, so it is the unknown RL, but second resistance belongs to the pure resistor, which is 10. Because both are resistance, I am going to add them. RL plus 10, which is just like resistors connected in series in DC. Because in resistance can be defined in DC and AC in the same way, plus XL squared. XL is going to be, yes, it's given as 20. And Z is given as 25. Instead of Z, I'm going to write in here 25. Then I'm going to square both sides of the equation. Square of 25 is 625 equals RL plus 10 plus 20 of square of 20, which is 400. Then if and here I forgot here there is a square. Then let's get this 400 to the left side. So RL plus 10 squared is equal to 600 minus 40, which is going to be 225. Now let's get the square root of both sides. R plus 10 is going to be 15. Then RL is going to be 15 minus 10, which is going to be 5 ohm. So answer is B. And question number 3. In an AC series circuit, our total is 200 ohm, XL is 600 ohm, and XC is 400 ohm. The total potential difference in the circuit by the phase angle difference of electric current. So the question is, what is the phase angle difference? So we know that theta is equal to tangent inverse XL minus XC divided by R. So tangent inverse. XL is 600, XC is 400, divided by R, 200. So 200 divided by 200, so it is 1. Angle whose tangent is 1 is 45 degrees. So positive 45 degrees, which means potential difference is leading the electric current. Potential difference is leading electric current by 45 degrees. The total potential difference in the circuit by a phase angle is current. So 45 degrees leading. Answer must be B. Question number 4. An AC source is connected across a series combination of 6 ohm resistor. So this is R. And a coil of pure self with inductive impedance, which is XL. And a capacitive impedance, XC. Calculate the total impedance. Total impedance equation Z, which is going to be root of R squared plus XL minus XC squared. So Z is equal to root of R is 6 square root of 6 plus XL is 24 minus XC is 16 and squared. I'm going to use the calculator. Square root of 6 is 236 plus bracket 24 minus 4, 16, close the bracket, squared. Answer is going to be 100. Root of 100 is 10. So Z is going to be 10 ohm in this question. And question number 5. A coil of self-inductance 100 over pi millihenry is traversed by a current of intensity 2 ampere under a direct potential difference of 18 volt. So if a coil is connected to a direct potential difference, so inductance XL does not exist in direct potential difference. Direct potential difference only exists in AC. Pardon, XL is only exists in AC, not in DC. So from the first sentence, I will calculate the resistance of this coil. So this coil is not a pure resistor, pure coil, not pure coil, so it is a resistor. So first I have to calculate the resistance of the coil. I will represent it by RL, which is going to be direct potential difference divided by direct current. So direct potential difference is 18 volts, so I am applying the Ohm's law. Direct current is 2 ampere. So this coil has a resistance of 9 ohm. Now second part of the question, but this time this coil, impure coil, is connected to an AC source. When it's connected to an AC source, of course there must be also XL. So find the maximum value of the current in the coil when connected across an AC source of effective value 50 volt and frequency 60 Hz. So because it's not a pure coil, it has a resistance which is RL, and I calculated in part A, this is 9 ohm. And also a inductor, this coil has an inductor part which is XL. So this XL must be calculated by using the equation 2 pi FL. 2 pi, F is given as 60, L is given as 100 over pi millihenry. Because it's millihenry, I have to multiply it by 10 to the power of negative 3. So then I will calculate XL as, now I'm going to use the calculator, this pi's will simplify. 2 times 60 times 100 times 10 to the power of negative 3, result is 12. So XL is going to be 12 ohm. Now this coil is attached to a generator whose effective potential difference is 18 volt. So find the current. How much is the current? I am going to calculate the maximum value of the current is the question. Yes, maximum value of the current is the question. But effective potential difference is given to us, 18 volt. Maximum potential difference must be effective value multiplied by root of 2. So 18 times root of 2 is the volt is the maximum potential difference. Then to calculate electric current, I need to calculate the Z because this coil is not pure. So I'm going to use the Z equation, which is RL squared plus XL squared square root. So RL is 9 squared, XL is calculated 12 squared. Result is going to be I think 15 that we calculated. 9 squared is 81 plus 12 squared is 144. So 225, yes, 15 is the answer. 15 ohm is Z. And after that, I will calculate the maximum value of the electric current, which is maximum potential difference divided by Z. Maximum potential difference is 18 root 2 divided by Z. Z is 15. So 18 divided by 15, 18 divided by 15, which is 1.2. So 1.2 root 2 ampere is the answer. Choice is going to be A, 1.2 root 2 ampere. So A is the correct answer. In an AC circuit, which of the following depends on the frequency? All depends on the frequency because XL is 2 pi FL, XC 1 over 2 pi FC. Both depends on frequency. Z depends on XL and XC. That's why all of them depends on the frequency of a AC source. Question number 7. A coil of self-inductance L 50 milliamp traversed by a current of intensity 2 ampere under direct potential difference. It's 7 is very again similar to question number 5. So initially it's attached to a direct potential difference of 20 volts. So we know direct potential difference is 20, electric current is 2. So first we will calculate the resistance of this coil. So V DC potential difference divided by IDC electric current, 20 over 2, which is going to be 10. 10 ohm is the resistance of this coil. This coil is not pure, as you see. Then it's going to be connected to a AC source. So now let me draw with resistance RL of 10 ohm and of course a coil of inductance. Inductance is given, but inductive impedance must be calculated because when we connected an AC source, so inductive impedance appears. 2 pi FL is the equation. 2 pi F is given as 100 divided by 180 divided by pi multiplied by L is 50. But millihenry must be multiplied by 10 to the power of -3. So these pi's will simplify. Let's calculate the XL. 2 times 180 times 50 times 10 to the power of -3. Result is 18. So XL is equal to 18 ohm. And this impure resistor is connected to an AC generator with an effective potential difference which is equal to 20 volts. So calculate maximum value of the current. Again, same method. We'll calculate IM. First, I have to get VM. If effective value is 20, maximum value must be 20 root 2 volt. Then Z must be calculated. Z is going to be, let me write, it's the RL squared plus XL squared. So Z is going to be root of RL is 10 square of 10 plus XL is 18 square of 18. So let's 10 squared plus 18 squared is going to have 424. Get the root. Answer is 20.1, 20.6. Yeah. Z is equal to 20.6 ohm. Now we can calculate maximum current because it's equal to maximum potential difference divided by Z. So 20 root 2 divided by 20.6. So choices are given without root, so we can multiply 20 by root of 2, which is equal to 28.20 divided by 20.6. Answer is going to be 1.37. 1.37 ampere is the maximum electric current. And question number 8. A voltage source of instantaneous value 20 sine 100 pi t. This is V maximum potential difference 20 volt, and 100 pi is the omega, is connected across a series combination of a pure resistor, this is R, and pure coil of L. Calculate total impedance. Total impedance is Z, but to calculate Z I need to know what XL is. R is given, but XL is not given. It should be calculated. XL is omega times L. Omega is 100 pi in the generator equation. It's given 100 pi. Pi is 3.14 multiplied by L. L is 0.2. So 3.14 times 100, 314 multiplied by 0.2, which is going to be 63, almost 63 ohm is XL. Then Z can be calculated R squared plus XL minus XC squared, but XC is 0 because no capacitor is connected. On XL squared, I will insert in here. R is 100, but squared. XL is 63 squared, then get the square root. 100 squared plus 63 squared, get the square root of the answer. Result is 118. So Z is going to be 118 ohm, so A is the correct answer. And question number 9, a voltage source of instantaneous value 20 sine 100 pi t is connected across a series combination of pure resistor of 100 ohm, so this is R, and self-inductance of L 0.2. We calculate the phase difference between the electric current and potential difference. His phase difference equation theta is tangent inverse XL minus XC divided by R. XC is 0 because no capacitor is connected. XL must be calculated. Then R is given. XL is omega times L. And according to the generator equation, omega is 100 pi again. This is omega. 100 pi is 314. L is 0.2. So I will get XL. XL is equal to 314 times 0.2, which is 63 ohm. Now I am going to apply the equation. Theta is equal to tangent inverse XL 63 divided by R, which is 100. Okay, use the equation. Shift tangent inverse bracket 63 divided by 100, close the bracket. Answer is 32.2. So result is 32.2 degrees. So correct answer is C. And question number 10, an inductive coil of resistance. As you see, this is not also pure coil, so it has a resistance. So this is RL. I am going to represent it by RL, 10 ohm. And self-induction, this is L. It's connected across the capacitance of capacitor 150. This is C. And an AC source of effective value 250 volt and frequency 50. Calculate the effective value of the alternating current. So IE is the question. VE is given. Very nice. If we calculate Z, then we can calculate IE very easily. This is a circuit which has a coil, but this coil is impure, and this impure coil has a resistance. I will represent this resistance by RL, 10 ohm, and also an inductor part. But this inductor part has an XL, it must be calculated. L is given 0.5 Henry, but we should calculate XL part. And also there is a capacitor. This capacitor has a capacitance which is 150 microfarad. That's why its XC must be calculated. Altogether, it's connected to a generator. So this generator has an effective potential difference of 250 volt and a frequency of 50 hertz. So first we should calculate what is XL, what is XC, then Z. After that, calculate effective value will not be hard. You know, XL is omega times L, or 2 pi FL. 2 pi FL. So 2 pi is 6.28. F is given as 50. L is 0.5. Let's apply the calculator. 6.28 times 50 times 0.5. Answer is 157. So XL is going to be 157 ohm. Let's calculate XC. XC is equal to 1 over 2 pi FC. 2 pi is 6.28. F is 50. C is given as 150 microfarad, but 150 microfarad must be converted to farad by multiplying 10 to the power of negative 6. So let's get the answer. 1 divided by 6.28 times 50 times 150 times 10 to the power of negative 6, close the bracket. Answer is 21.2. 21.2 ohm is XC. Now we can calculate as Z. Z is equal to root of R squared plus XL minus XC squared. R is coil has a resistance of 10 ohm, square of 10, plus XL minus XC. XL is 157, XC is 21, but squared. So let's use the calculator. 10 squared is 100 minus bracket 157 minus 21, close to bracket, get the square. Okay, there's a mistake. Once again, square root of 10 is 100 plus, I said minus, but plus 157 minus 21, close the bracket, squared. After that, get the square root of answer. Result is 136. So Z is 136.4 ohm. Now we can calculate effective electric current by Ohm's law. V effective over Z. V effective is 250. Z is 136.4. So 250 divided by answer, which is 1.83. So effective value is 1.83 ampere. So C is the correct answer. And question number 11, an inductive coil of resistance. Again, this is not a pure coil. This is RL. An inductive impedance, which is XL, connected across an AC source of effective value 200 volt and frequency 60 Hz. Calculate impedance. Okay, inductive coil of resistance, the inductive impedance is 60 Hz, and this is just like a RL circuit. So first you should get impedance. Yes, the answer is impedance. Question is impedance, in fact. Impedance can be calculated by RL squared plus XL squared. So this is that easy. All other givens are not required. RL is 80 squared. XL is 60 squared. End result is going to be, if you use calculator, it's going to be 100 ohm. So C is the correct answer. And question number 12. A capacitor of capacitance 400 microfarad is connected in series a pure resistor of resistance 10 ohm. So let's connect the circuit. There is a capacitor, and this capacitor is connected in series with a pure resistor of 10 ohm. Connect this 10 ohm across a source of frequency 250 divided by pi. So we are going to connect this to a generator with a frequency 250 Hz. So this is F, this is C. If the effective value of the potential difference across the capacitor is 18 volt, so this is 18 volt. So what is the effective potential difference across the pure resistor? So calculate VR. VR is the question. Because they are in series, if we calculate electric current across the capacitor and resistor, because they are in series, they have equals the same electric current. So we can calculate VR. So we will use capacitor information to get electric current. How much is the electric current? So that's to find first I have to calculate XC. XC is equal to 1 over 2 pi FSC. So 1 over 2 pi is multiplied by F is given 250 divided by pi times C is 400 microfarad. Microfarad must be converted to farad by multiplying 10 to the power of negative 6. Now by using calculator I will calculate XC first. So this pi's will simplify. 2 times 250 times 400 times 10 to the power of negative 6. So this is 0.2. 1 divided by answer 5. XC is found as 5 ohm. Now I can calculate electric current, because according to Ohm's law, electric current across the capacitor is VC, potential difference across the capacitor, divided by XC. Potential difference across the capacitor is 18 volt. XC we found 5 ohm. So 18 divided by 5, which is 3.6 ampere. So 3.6 ampere electric current is across the capacitor, and the same electric current passes through the resistor because they are in series. Now I will calculate VR again by using Ohm's law. So I times R. R is 3.6 ampere multiplied by R is given as 10. It's going to be 36 volts. So potential difference across the capacitor is 36 volt. And question number 13. An AC source is connected across a series combination of coil of certain resistance. Now this is again impure coil because it says coil of certain resistance. So this coil must have a resistors RL, I will say that. An inductive impedance 80 ohm, which is XL of this coil. And a pure resistor, a second resistor is connected. A resistor is a device is connected. I will say it is just R. If the total impedance of the circuit Z is given, what is the value of the resistance of the coil? So yeah, this is in fact, if I represented the circuit, this circuit has an impure coil with a resistance RL and a inductance of XL. This is the coil because it's impure. It has both resistance and inductance. And also another resistor is connected in series, which is R. And total impedance is given for this Z. So I am going to say that this is a RL circuit. So Z is going to be root of R total squared, because I am going to add these two resistance, because, just like in DC circuit, how we add them in series. R total squared plus XL squared is going to be Z. As Z is given 25. If I square both sides, I can remove the root. So Z squared, which is 100 squared, is equal to, if I remove the root, it's going to be R total squared. R total is what? RL, which is unknown, that's I'm going to find, plus resistance of the other connected resistors, which is given in the question as 40 squared, plus XL squared. XL is 80 squared. So 100 squared, if I want to calculate RL, so RL plus 40 squared must be equal to 100 squared minus 80 squared. Now I'm going to use the calculator to calculate how much is this. 100 squared minus 80 squared is equal to 3,600. 3,600. Then I'm going to get the root of both sides. So root of 3,600 is 60, which means RL plus 40 is equal to 60. So then when we take this 40 on the right side as negative, RL becomes 60 minus 40, which is going to be 20 ohm. So C is the correct answer. In an AC circuit, which of the following is inversely proportional to frequency? We know R doesn't change, no effect, because in the equation of R we don't have a frequency. XL is, equation of XL is 2 pi FL. Yes, that's why F increases, XL increases, but we want it inversely changing. XC is 1 over 2 pi FC. Yes, this is inversely proportional. As F increases, XC decreases, or F decreases, XC increases. So this is the correct answer, B. In an AC circuit, which of the following does not depend on frequency? Yes, this is the resistor. We just learned that resistor of a resistor is calculated by an equation: rho, type of the conductor, L, length of the conductor, area of the conductor. Nothing else affects the resistance. Temperature also affects, but not frequency. Question number 16. An AC source is connected across a series combination of resistors. A resistor, 12 ohm resistor. Let me join it. And a coil of pure self with impedance 14. It's a pure coil, so XL is given as 14 ohm. And a capacitance with a capacitance, capacitor impedance is 5. And then also XC. XC is 5 ohm. Calculate total impedance. This is very easy. Just really going to use the equation for Z. Z is equal to root of R squared plus XL minus XC squared. So Z is equal to R is 12 squared plus XL is 14, XC is 5, so squared. Now use the calculator. 12 squared plus XL minus XC, 14 minus 5 squared equals to 225. When we get the root of 225, result is going to be 15. 15 ohms the total impedance of the circuit. So this is all about the mystery questions of RLC series circuit.